Hello and welcome to another session of solving problems with Elixir. We are going to continue to do some more practice to learn our function design recipe. And the problem we are going to design the function for today is that given a point xy on Cartesian plane, find its distance from the origin. So what does that mean? So if we have a point xy, we want to find the distance d from the origin, and that distance d is given by d equals square of x added to the square of y, and then we take the square root of that. So let's look at some example cases. So if we have x, y, and d here, and if x is 3, y is 4, we'll get 5 as the distance. If x is 6, y is 8, we'll get 10 as the distance. If x is negative 12, y is 5, we'll get 13 as the distance. So this is the analysis of the problem. And at this point, once again, I would encourage you to pause the video, try this recipe for yourself. That is the best way to learn. And then once you are done, you can come back and look at my solution and learn from that as well. With that said, let's get started. I'm going to jump to my editor and start with step 1, which is to write the signature of the function. So we'll start with that spec, and let's see, we can name the function as distance from origin. It's going to take a number and another number, and it's going to produce a number. In step 2, we are going to write the purpose inside the doc attribute. So that will be compute the Euclidean distance of a point xy from the origin. Step 3, we are going to write the stub. So that's with the def distance from origin. So what should be our parameter names? So once again, we can rely on some information that we have previously collected. And in this case, we will look at the purpose and note that the distance of a point xy is what we want to find. So we want to bring that domain information in our function definition as well to make it clear that it is point xy that we are looking at. So let's call these parameters x and y, start the do block, and then output a value of the same type as the signature is indicating, which is a number. So we're going to have 0 there, and then jump on to step 4, where we are going to write the test. So the first test is that 3 and 4 should give me 5. So test 3, 4 should give 5. We're going to make an assertion. Distance from origin 3 and 4 should be equal to 5. Let's copy this test few times. And the next test is 6 and 8 should give us 10. And then the last test is -12 and 5 should give us 13. So there we have it, step 4 with 3 tests written. We are going to run the mix test here, and this is just to make sure that the stub that we have written and the tests we have written are well formed and they are syntactically correct. So we see that we have 9 tests, 3 failed, and that is expected because of the value differences. And it is saying 3, 4 should give me 5, but we are getting 0, and that is just fine because we have not implemented our function yet. Now let's move on to the step 5, writing the body, and this is the implementation. So we are going to square our inputs, add them, and take the square root of that. So to take the square root, let's go back to the body and start to implement. And in order to take the square root, we are going to use a float module. And inside the float module, we have a power function that takes 2 arguments. One is the base and other is the exponent. So the base is going to be the sum of squares. And in a previous exercise, we had already defined a function square, so we are going to leverage that. And this is very common in functional programming, where you are solving small problems and then larger problems will be composed of other smaller functions. So in this case, we are going to say that we need square of x. We're going to add this to square of y, and we are going to raise it to the power of 1.5, and that becomes our expression. So let's go down to the console again and run mix test, and our tests are still failing, and it is saying function clause error, no function clause matching in float. We don't quite understand it yet, but if we go down a little bit, looks like there is some issue in the type of number. So it's expecting the base to be float, but we are providing it as an integer. So let's look at the signature of this function, which is POW, and it is saying yes. So the first argument should be float and second could be a number. In our case, in our test cases, we are using the integers. So the sum of squares of the integers is coming out to be an integer, and that's why it is complaining. One trick here we can do to debug this is to force one of the integers to be a float by simply multiplying it by 1.0, and then let's see if this does the trick. So we're gonna run mix test, and yes, now we have all 3 tests that are passing, and our function is running as expected. So there you go. So we have the full recipe. Once again, went through the steps of starting with a signature, then purpose, then writing the stub, and then finally writing the tests, implementing the function and testing. And in this case, we also got a chance to debug our function based on the results we were getting.